Hello, everyone, and welcome to another session of the Ask the Expert series with Altair. Session is going to be about Feko's component library and array tool.
Component library feature, it has a very powerful feature. It doesn't require any electromagnetic knowledge. The library consists of 50 plus antennas and eight platform models. You can see on the screen. It has all the basic to advanced antennas in the portfolio or in the library. And bringing the antennas into the CAD FICO will be in two to three steps. A couple of clicks, you have the antenna, desired antenna that is available in the library can be brought into CAD FICO. Okay, and antennas in this particular thing, antennas support frequency scaling, solar variants, configurations, and ground plane options. All these things are supported with this in this particular component library feature. And as I mentioned, new antennas, we keep on adding the new antennas every update in each and every important major update whenever we do. You can see here are some of the some of the recent edition of the antennas like blade antenna, stub fed slot, annular slot, E and H plane horn, shunt fed monopole, shunt fed dipole, all the antennas, right? And also in case if you have anything that you are interested in and would like to work with the antennas and it is not available in the component library, please reach us. We are constantly enhancing this feature. We would like to add these antennas appropriately, and the development team we can add it and we can have them available in the upcoming versions. Then you can see over here application micro library extensions. Just as I told you, the second important part is the array tool, which is available in the application macro. Actually, in 2021 and 2022 versions, we kept major efforts in improving the GUI and also bringing the scripts into CAD macro, into the CAD FICO. Actually, what happens is in the earlier case, people used to come to us and asking for the script, whether we have the script for this particular application and stuff. And then we used to give the script for them. They're going to add them into application macro and they're going to use that appropriately. But in this particular versions, as I mentioned, we added all the scripts based on the nature of the script. It is available into that particular group so that you can click and utilize it in efficiently. You can see over here we have scripts available for model construction, import or export, or utility, or radar cross section, and simulation. Based on the script nature of the script, we grouped them and I kept tag them into appropriate icon, and that is available in the application macro. Okay. And in the today's demo, we'll be using the generate antenna array plugin or gen antenna array. And post FICO macros also similarly based on the nature, we also grouped them and added into the post FICO, and probably maybe plotting of data, field calculations or S parameter calculations, or import or export data. All the scripts are available in post FICO. Yeah, you can choose the base model of nature of your interest, and you can generate the antenna array. Use union array, simplify a union, and choose the number of elements you want, and then you enter the punch in the offsets appropriately. And after that, the following screenshot will look and asking about the amplitude type, what kind of amplitude you would like to excite it, and also the phase difference you would like to assign to this particular thing. Let us start working on the demo part. I would like to start to launch the CAD FICO now. I'm going to type in FICO. I want to use the latest and greatest is 2022. I would like to use that particular thing. I have the 2022 version is available. I launched it. I would like to go to the CAD FICO. My CAD FICO is over here, and I would like to use a create a new model. Okay. And now I want to go and use the component library feature. Very simple. Just click the component library feature. As I mentioned over here, we do have 50 plus antennas available in this particular library feature. And you can choose the antenna which you would like to work or the platform which you would like to work. And all these platform models are not confidential and they can be shared with any of the project needs. You can use them appropriately. These files are not confidential. More than that, these platform models are not at all, are more generic in nature. And then I would like to go ahead and bring the antenna into CAD Feko. My antenna will be, I would like to choose the patch antenna over here. If I type the patch, there are several options are available: aperture coupled, circular, and elliptical of nature, rectangular, and truncated. You can choose what you like. I would like to choose patch antenna for this particular application. You see over here, it is showing the frequency versus excited, the S11 coefficient, the versus reflection coefficient, what we can call, and also the far field option. Okay, then we can go to the next, and then my frequency will be, I would like to go with 8 gigahertz. Okay, you can choose what frequency. This is the couple of clicks as I told you. Frequency, 8 gigahertz, and you can choose method of moments or FEM or FDTD. I would like to choose method of moments finite ground plane, and also it is asking for me add configurations. How many configurations, like whether you want a single frequency or you would like to solve this particular patch antenna for a frequency range. I would like to use this for the single frequency at 8 gigahertz. Okay, you can add the ground plane, align created component model, add to model. Okay, and you see over here, we do have the patch rectangular antenna available. Okay, and this is our base element to work with. Let me save this particular model as patch antenna. I'm going to create a folder on my desktop and I would like to tag it as a Pico patch antenna. And I would like to save it as patch antenna. I have my unit element available. Now I am ready for my antenna array script. I can use my antenna array script to generate the antenna array. How can I do that particular thing? I can go to the home tab and I would like to go to the application macro and I can go to model construction and generate array. This is how we are going to use the script and we can get the antenna array. Before that, I need to do some additional inputs that are required for generate antenna array. I need the offsets of the patch antenna so that when I run this particular antenna plugin, I can enter those numbers. What I would like to do is first I would like to calculate the offset. My X offset is 0.03313 meters. I would like to copy those coordinates so that those things will be handy when I would like to use them. My X offset I copied over here in a Word document next to me, and also I would like to calculate my Y offset. Control C. Next thing is I got my X offset and Y offset. You can see over here. I'm gonna use them when I need it. I'm gonna close it. Now it is the time to run the antenna array script. Go to application macro, home tab, scripting group, application macro, go to model construction and generate antenna array. And I got my window is available over here. It is there right next to me. Generate antenna array window is there. You can see over here, it is looking for the base element and destination configuration where it has to go, and linear or planar array. Also, you can have the custom array, also you can choose it. I would like to choose the linear array. You can have the union, simplify, mesh. All these things can be selected appropriately. Okay. And also I have array elements. I have like 8 array elements in X direction, 8 array elements in Y direction. This is the offsets I am looking for, X offset and Y offset. I already have them available in my Word document. I would like to bring them and keep it over here. My X offset and my Y offset. I got my X offset and Y offset. I am like having 8 by 8 elements I chose. My next step would be importing excitation values. You can use, as I mentioned, you can apply the amplitude, maybe uniform amplitude, triangular, cosine squared, custom, you can do all the things. Similarly, you can have the phase difference between the two elements, successive elements. You can use the successive elements phase difference between first element to the second element. Okay, you can plug in the numbers there and you can use it. And you see over here, my script is running and it is generating 8 by 8 elements for me. And you can see over here, the constantly script is running and it like 8 by 8 means it's almost like 64 elements. It ran for me. And you see over here, I have my 8 by 8 array is available right now on my screen. And after that, what you can do, you can perform the union of these 64 elements. You can perform the union operation. How can you do that? Go to construct tab and go to modify group and union. That means this is got, you can have the union operation performed now. Once you have the union operation done, then we can go to the solving part of this particular thing. In case if you would like to do the same thing from the scratch, it might take a day or two for you. The component library feature plus array tool is going to help you a lot to solve the problem very efficiently in no time. You see over here, in less than 10 minutes, I have my patch antenna brought into CAD Feko, and also I could able to generate the antenna array, and then I can run the simulation on the Feko solver. And you can forget about all other options, and you can go to the mesh option, and you can go ahead and mesh it, and then once it's meshed, then you can go ahead and run the Feko solver. It might take a little while. That's fine. Once it's done with the machine, okay, you see over here, it is done with the machine. Then you can go to the solver and you can use the Feko solver to run this particular problem. You can solve this particular problem with method of moments based on the availability of resources, or you can solve the problem with the MLFMM as well. I just went ahead and solved this particular problem using MLFMM. I chose MLFMM over here, settings, and I saved this particular part. And then I would like to go ahead and hit the FICO solver button. That's it. It will run the simulation and it can show the results for us. I already had the output, which I ran it again earlier so that we can save some time over here. You see over here, this is the radiation pattern of an 8 by 8 patch antenna array, which is working at 8 gigahertz. You can see over the gain plot over here, how the gain, and also you can plot the polar plot. You can see the polar plot, how it looks. It's the theta cut and phi is equal to 0 degrees. And also I can plot the reflection coefficient for me because it's only one point we are going to get at 8 frequencies. Yeah, you can see there are a lot of things are available. Yeah, you can plot that one. Each element, it is basically showing for each element. Yeah, you can see over here 23 points. And you can select for all the entire each element how it is showing the reflection coefficient. Again, I'm coming back. We could able to just a summary. We could able to use the Feko component library and the array tool to bring the patch antenna into the CAD Feko and generate the antenna array. And in no time, we have a 8 by 8 simple array brought into constructed into the CAD Feko, which saves a lot of time for you. And then you can use the MLFM solver or method of moment solver based on the availability, and you can look into the results. Okay, friends, and thank you. Hope you enjoyed the session.